Good afternoon, students, and welcome to the Q&A session. So, in the last class, we started with the chapter Light, and today we are going to cover the second part of this chapter, Light. So, let's start the chapter, students. So, the name of the chapter, as we know, is Light, Reflection, and Refraction. And what did we do in the previous class was we studied about the plane mirror and the reflection due to plane mirror. We also saw the characteristics of images which is formed by the plane mirror and the uses of plane mirror, and that's where we ended the class. In today's lecture, we are going to start the spherical mirrors. Okay. So what are the prerequisites for today's class? Let us understand that. So you need to know the basic mathematics which is required for solving basic problems. Second, you need to understand the plane mirrors, the laws of reflection, right? You need to understand about what is object and what is image. And let's talk about the weightage of this chapter. So light, reflection, and refraction has a weightage of 10 marks in the board exams. So if there is an 80 marks paper, you can expect around 10 marks of question coming from this chapter. So that's why this chapter is very important for you, both in terms of theory which is being asked from this chapter and the numericals which are being asked from this chapter based on mirror formulas and lens formula, which we are going to cover in the coming lectures. Now let's see what we are going to study today. So in today's lecture, we'll cover what are spherical mirrors, and then we'll also cover what are concave mirrors and convex mirrors. So these are two different type of spherical mirrors which we are going to study about. Now let us start. What are spherical mirrors? So first of all, let us reconnect the dots which we did in the previous class. What was plane mirror? So plane mirror was a glass surface where what did we do is that we silvered one of the side, and then the other side became the reflecting surface, right? So this is how we make a plane mirror. Now in terms of let's come to spherical mirrors. Spherical mirrors, it is not plane, it is not one surface of a plane, but it is a part of a sphere, and that's why we call it spherical mirror. So let's understand what are spherical mirrors. So spherical mirror is that mirror whose reflecting surface is a part of a hollow sphere of glass. For example, let's say you have this hollow sphere, right? And in this hollow sphere, if we take a part of this hollow sphere, right? So if we cut this hollow sphere by a plane, so this part of the hollow sphere will be a spherical mirror. Now it depends that which surface are you silvering. If you silver, let's say this is that part, and if you are silvering this part, outer part, it will become a concave mirror. Why? Because the reflecting surface is forming a cave, and that's why it is called a concave mirror, right? The other option is you silver this inside surface. So when you silver this inside surface, the outer surface becomes the reflecting surface. In that case, this becomes a convex mirror. So it will totally depend on which surface are you silvering and which surface is becoming the reflecting surface. Let us understand that in more detail. So when a parallel beam of light rays falls on a plane mirror, it is reflected as a parallel beam. This we saw in yesterday's class, that if you have a plane mirror like this, so if there are parallel light rays coming, these parallel light rays on reflection, they will become parallel to each other. So this is the reflection on plane mirror. But in case of spherical mirror, it is not this. It will not be like this. So in that case, the parallel light rays, after reflecting from a spherical mirror, either will converge at a point or will appear to diverge from a point. So when it is converging at a point, it is called converging mirror or concave mirror. And when it is diverging from a point, it becomes a convex mirror or a diverging mirror. So let us see how to find whether it is concave mirror or convex mirror. So spherical mirror, what it will do, it will either converge or diverge the parallel light rays. So I'll give you a brief introduction of that. So here, in case of concave mirror, when this parallel light rays, after reflecting, they will converge at a point, and then we say that this is a converging mirror. And in case of a convex mirror, the parallel light rays, this diverges, and when it diverges, it will appear to be coming from this point. It will appear to be diverging from this point, and that's why convex mirror is called a diverging mirror and concave mirror is called a converging mirror. Let's understand it further, students. So as I said, there are two types of spherical mirror. One is convex mirror and other is concave mirror. Now, and we also discussed that these spherical mirrors are a part of a hollow sphere. So let's say if this is the hollow sphere which you are seeing on your screen. So a part of that, let's say we have cut a part of that. So you can see that, this is a part. Uh, so this is a part where this is your front side and this is your back side, right? So this is a part of a sphere. Now, if we are silvering the outer part, for example, if I show you here, if I make a curve here with my hand, so if I silver this outer part, right? So this part, the inner part becomes your reflecting surface. This inner part, which is your reflecting surface, is basically a concave mirror. Now, so reflecting part is this inner part, which is forming a cave. Concave means which forms a cave. So this is your concave mirror here. Reflecting part is inner part and the silvered part is this outer part, bulging out part, right? Now, if you see this convex mirror, now in case of convex mirror, what you will do, you are going to silver the inner part. So I am silvering the inner part. The outer part becomes my reflecting surface. And here the reflecting surface, since it is the outer part, so it is called convex mirror. So is it clear to everyone, students? Did you understand what concave mirror and convex mirror are? I'll explain it to you. Yeah, I'll explain it to you further. So, if you see here, in case so if you see here, as I said, in concave mirror, if this is my sphere, right? And in this sphere, if I cut it, you will find something like this, a part of that sphere. Now, if I take it here, this is the part of the sphere, right? I have cut it by a plane like this. This is the part of the sphere which has come out. Now, in this part, if I silver this part, the outer part, this inner part, this is your inner part, right? Now the outer part is silvered, the inner part is your reflecting surface. So this is an example of concave mirror. Are you able to visualize this?
Yes, sir.
Okay. Now in convex mirror, as I said, when we cut it here, now let's say this is your convex mirror. Now you have cut it from here, for example. If I have cut it from here, so this is the part of the sphere which will come out. This is the part of the sphere. Now, if I am going to silver this portion, right? In that case, this is your reflecting surface. So the reflecting surface is bulging out. So this is your reflecting surface. This is bulging out. So if I draw a two-dimensional figure, this is your silvered part. And light ray will come and get reflected here. And in this case, this is my silvered part. Light ray will come and get reflected here. Is it clear now? Are you able to visualize all of this now?
Yes, sir.
Okay. So once you are able to visualize, then you will be able to understand the whole concept better. Now let's go ahead, students. So, again in two-dimensional figure, if I, explain this. So as I said, if I cut this, uh, spherical surface by a plane, then when we silver the inner part, the outer part becomes the reflecting part. And similarly, if I cut the other part where I silver the outer part, the inner part becomes the reflecting part, right? So reflecting surface in this case, this outer part is your reflecting surface, right? This outer part is your reflecting surface, and here this inner part is your reflecting surface. When I make this kind of parallel lines here, it shows that this is the silvered part. Okay, so which is opaque surface. And similarly, reflecting surface here is inner surface, and outer surface is your silvered part, which makes it mirror. So this is your concave mirror, and the left figure, this is your convex mirror. Is it clear, students? You are able to understand concave and convex now? Let's go ahead. So as I said, in convex mirror, the parallel light rays which comes to the principal, which is parallel to the principal axis, after reflection, it diverges. And when you bring it, when you bring it backwards, when you extend it backward, for example, you will see that these are coming from this point, right? So that's why this is called a diverging mirror. And it appears to be diverging from this point. We'll come to know what this point is specifically called in the next slides. But it appears to diverge from a point. So this is called a diverging mirror. Now, in case of concave mirror, this is also called a converging mirror. Okay. So if you see this concave mirror is called a converging mirror. Now, spherical mirrors, as I said, these are two types of spherical mirrors. One is concave mirror and other is convex mirror. So this is the two-dimensional figure of concave and convex mirrors. Now in this figure, if you see, this is a part of the sphere, and the center of that sphere is specifically named as a center of curvature. The mirror, it is a part of a sphere, right? The center of that sphere is called center of curvature. So a concave mirror is that mirror in which the reflection of light takes place at the concave surface. So this is the concave surface. So reflection takes place at this concave surface, and that's why it is called concave mirror. So concave surface is the bent in surface which is going inside, bent in surface. If you take a spoon, the side by which you eat, that is the bent in surface. That is one example of concave mirror which you can relate to. Convex mirror is that spherical mirror in which the reflection of light takes place at the convex surface. So here the convex surface is the bulging out surface, right? So this is the bulging out surface. The bent in surface is the concave surface. Clear? So again, if I take an example of the spoon, the surface which is below, when we eat, the surface which is below the surface in which you keep the food is basically the bulging out surface, and that is the convex surface. Clear, students? So common terms, before we go further, you should understand the common terms which is required to define a spherical mirror, whether it is concave mirror or convex mirror. So let's understand the first term. So because these mirrors are a part of a sphere, that sphere will have a center, and that center is called center of curvature. So center of curvature of a mirror is the center of the sphere of which the mirror is a part. So since this mirror is a part of this sphere, which you can see on your screen, the center of this sphere is called center of curvature. Now, second part is pole. What is the pole of the mirror? So the geometric center of the spherical surface of mirror. So this is the surface, spherical surface. The geometrical center of this spherical surface is this point, right? So because you are seeing this, this is a two-dimensional figure which you are seeing. But in general, so this will be, if you take your palm and stretch it like this, the center will be somewhere here, right? So center is somewhere here, which is called the pole of the mirror. Okay. So geometric center of the spherical surface of the mirror is called the pole of the mirror. Now, third point which you should understand is principal axis. What is principal axis? The line joining the center of curvature and pole of the mirror is called principal axis. So this is the line. If you join this center of curvature and pole of the mirror, the line is called the principal axis. Clear, students? Now, fourth point of importance is radius of curvature. Now, as we know that this was a part of a sphere, right? This spherical mirror is a part of a sphere, and that sphere will have a radius. Now, this is that radius, right? If you take this, if you draw this whole sphere, right? So this is the radius of that sphere, and that radius is called the radius of curvature. So radius of curvature of a mirror is the radius of the sphere of which the mirror is a part. So out of this whole sphere, mirror is a part of that sphere, and the radius is the radius of that whole sphere. So radius of curvature, that is called radius of curvature. So these are four very important terms which we will keep on using when we are studying this chapter further. First was center of curvature, second pole of the mirror, third principal axis, and fourth radius of curvature. Clear, students? If you want to note down the definitions, you can note down the definitions quickly on your notebook. Have you done? Are you done with this? Have you noted it down? Okay, so let's go ahead. The center of a curvature of a concave mirror. So two things we noticed here. Now we saw this concave mirror is a part of this sphere. Center of curvature is a part of this sphere. So in this case, center of curvature is in front of this mirror. And here in this case, if you complete the sphere, you will find the center of curvature which is behind the mirror. So center of curvature of concave mirror is in front of it, and center of curvature of convex mirror is behind it. So here the center of curvature is behind the mirror, and here it is in front of the mirror in case of concave mirror. Again, this will be useful when we are doing the mirror formula. So the sign convention is dependent on all of this, right? So you need to understand, if I talk about concave mirror, the center of curvature is in front of it. If I talk about convex mirror, the center of curvature is behind that. Clear, students? That portion of mirror from which reflection of light actually takes place is called aperture of the mirror. So aperture of the mirror tells you the size of the mirror. So the aperture of the mirror represents the size of the mirror. So I was always showing you this palm, right? This curved palm. So this is the size of the mirror. This will be the aperture of the mirror. So generally this diametrical portion, let's say, I'll draw it here and will explain you. So let's say, as I said, this is the mirror, right? It will look like this. Now, this is a spherical part, right? If you see it from here, you will see it as a sphere. The diameter of this from here to here, this is called the aperture of mirror. So aperture of mirror or size of the mirror. Is it clear? Do you understand what aperture of the mirror is now? We are talking about this concave mirror. This is this outer part, which is being silvered. Inner surface is your reflecting surface. So aperture would be the size of this. So that portion of mirror from which the reflection of light takes place is called aperture of the mirror. Is it clear, students? Okay. Now, let us understand two very important terms, that is principal focus and focal length of a concave mirror. What is principal focus and what is focal length of a concave mirror? So let's understand, students. So here, the principal focus of a concave mirror is a point on its principal axis to which all the light rays which are parallel and close to the axis converge after reflection from the concave mirror. So let's say you have this concave mirror. I'll draw it here. And in this concave mirror, there are parallel light rays coming, which are parallel to the principal axis. After reflection, they converge at one point. The point at which these light rays after reflection converges is called the focus of this, principal focus of this converging mirror or concave mirror. Okay. So I'll read the definition again for you so that you understand it well. Principal focus of a concave mirror is a point on its principal axis to which all light rays which are parallel and close to the axis. So this is the principal axis. These light rays which are, incident on the mirror, they should be parallel to the principal axis and close to the principal axis. Okay, so parallel and close to the axis converge after reflection from the concave mirror. So after reflection, you see they are converging at this point, and that point is called principal focus. And if this is your pole, the distance between the pole and the focus is represented by small f, which is the focal length of this mirror. Is it clear, students? So since all the reflected light rays actually pass through the focus of a concave mirror, therefore a concave mirror has a real focus. So yesterday when we were discussing about the image, there were two kinds of image we discussed. One was real image and other was virtual image. So real image was where the actual light rays met, and virtual was where it appeared to be meeting at that point. So because in this focus, the actual light rays are meeting, and that's why this focus is called real focus. So in case of concave mirror, the focus is real because actual light rays are meeting at that point. The focus of a concave mirror is in front of the mirror, which we have already seen. Now, since a concave mirror converges a parallel beam of light rays, it is called converging mirror. This we have already discussed. So is it clear the focus of a concave mirror and focal length of a concave mirror? Are you clear on the concept of this? Okay, good. Let's move ahead. Now, principal focus and focal length of a convex mirror. Now, the principal focus of a concave mirror is a point on the principal axis from which a beam of light rays initially parallel to the axis appears to diverge after reflected from the convex mirror. So, for example, this is your convex mirror. Now, the parallel light rays which are parallel to the principal axis, after reflection, it will diverge. And when you extend it backwards, these diverging rays will appear to be coming from this point. So if the observer is on the left of the mirror, what he will observe that these two light rays are coming from some point. That point is called the focus. And because here actual light rays are not meeting, it is appearing to meet at a point, and that's why this focus is actually a virtual focus. So this is a virtual focus. And the distance between this pole and the focus here is focal length. Is it clear, students? The concept of virtual focus here in the case of convex mirror, that is diverging mirror, and the distance known as focal length. Is this concept clear for convex mirror as well? Okay, good, Raghavi. The convex mirror has virtual focus and its focus is situated behind the mirror and not in front of the mirror. Okay. All of this concept, again, I'll reiterate the fact that these concepts will be helpful when we start doing the mirror formula and the numericals based on that. So, physics is all about concepts. Once you understand the concepts, it is just mere application of those concepts in solving the numericals. Sign convention will be clear only when you understand these concepts. Okay, let's move ahead, students. Now, principal focal and focal length of spherical mirror. The focal length, so, the focal length of a concave mirror is the distance between its pole and principal focus. It is denoted by F. So in case of concave mirror, this is your focal length. And in case of convex mirror, this is your focal length, right? The focal length of a spherical mirror is equal to half of its radius of curvature. Now try and understand what it means. If I complete this sphere, now let's say this is your center of curvature. So this is your radius of curvature, that is from here to here, this complete radius of curvature. Focal length is the center of, the line segment joining the center of curvature and pole. So that means your focal length will be half the radius of curvature. So F is equal to R by 2, or you can also say that radius of curvature is 2 times the focal length. So this is the first formula in class 10th in the chapter of light. And there are numericals based on that, which we will see in next slides. So please write down this formula. This is very important. The relation between focal length and radius of curvature. It is for both spherical mirrors. In case of concave mirror also, F will be equal to R by 2. And in case of convex mirror also, F will be equal to R by 2. So again, if I show it here, if I complete this sphere, this is your radius. Sorry. If I complete it here, so this is your radius. And if I write it here, so you will find that focus is in between the pole and the center of curvature. And the relation again here is also equal to F is equal to R by 2. Clear, students? Okay, let's go ahead. So where F is the focal length and capital R is the radius of curvature. This is general notation which we use to represent the focal length as well as radius of curvature. Now let's see the first example, students. Find the focal length of a convex mirror whose radius of curvature is 32 centimeter. So what is given here in the question is radius of curvature is 32 centimeter. Whenever you get a numerical, you should always write what is given in the question. And then what has been asked in the question. So find the focal length. So you have to find the focal length, right? Just now we saw a relation where we saw that F is equal to R by 2. Now this will be, if you put the value of R as 32, this will be 32 by 2, which is equal to 16 centimeter. So the focal length in this case is equal to 16 centimeter. Is it clear, students? Did you understand the application of this formula? So one of this will be given, either radius of curvature is given or focal length is given. You have to find the other one. So if F is given, you have to find R, and similarly if R is given, you will have to find F. So let's see the next question. Have you written down the question and the solution of this question? Okay, so let's go to the next question. You have to attempt this question on your own and tell me the answer.
Sir, 40 centimeter.
Yes, correct.
40 centimeter, sir.
Very
40
good.
centimeter.
Very good. So let's see what is the question here. The focal length of a spherical mirror is 20 centimeters. So F is equal to 20 centimeter. What is its radius of curvature? So you have to find R here, right? Now the relation which we have seen is F is equal to R by 2. If I take 2 on the other side, you have 2F is equal to R. Now you have to calculate the value of R, and the value of F is already given. So 2 into 20, this will be equal to 40 centimeter. So this is what had been asked in the question, and this is how you solve this question. Okay. Okay. Most of you have already answered. So I'll just remove this. Now let's understand ray diagrams, students. So what is a ray diagram? So generally it is a method of locating the position, size and nature of the image. So, you know, when you have an object, you will draw this ray diagram to find out the position of the image, the size of the image and the nature of the image. Nature of the image means, is the image real? Is the image inverted or, erect? Is the image magnified or diminished? We'll understand all of this using the ray diagrams concept. So ray diagram is a method of locating the position, size and nature of the image. So for example, an image, as I said, it can be erect image. So the image can be erect. Second, the image is magnified. It can be a magnified image. You can see the object is the palm of the hand and the image is much more larger than the size of the object. So this is a magnified image. And here it is an inverted image, right? You can see it is an inverted image. And fourth, if you see, this is a diminished image. The size of the object is larger than the size of image, or size of image is smaller than the size of the object. So these are the different nature of images: erect, magnified, inverted and diminished. These are all nature of images which we'll understand once we draw the ray diagram. In a particular case, when the object is placed at some position, you will have different positions of image, and similarly you will have different nature of image which is being formed. Clear, students? Okay. So rules for obtaining images formed by okay rules for obtaining images formed by concave mirror. So rules for making ray diagram. So there are 4 rules which you need to remember to make the ray diagram. So let us go one by one. First is, a ray of light which is parallel to the principal axis of a concave mirror passes through its focus after reflection from the mirror. So if you see here, the incident light ray is parallel to the principal axis, right? Now, after reflection, the light ray will pass through the focus. This is the first rule. Whenever you have a light ray parallel to the principal axis, whenever you have an incident light ray parallel to the principal axis, the reflected light ray will always pass through the focus. So see, this is your incident light ray. After reflection, the light ray will always pass through the focus. Now here also, basically, the law of reflection is being followed. How is it? Let us understand. Whenever, because this is a part of a sphere, right? This is a part of a sphere. Now, whenever you join the center of curvature to this point, any radius, right, will always be perpendicular to the tangent, right? You would have studied all of this in class 9th circles chapter. Have you studied it? The normal is perpendicular to the tangent in case of a circle. Whenever you have a circle, when you draw a radius here, this will be perpendicular to the tangent. Have you done this in mathematics in class 9th? I hope you would have done it in class 9th. Good. So now, we know that this is the normal. So what was the definition of normal for plane mirror? So in plane mirror, we saw that at the point of incidence, let's say this was the incident ray, at the point of incidence, the perpendicular to the surface of mirror was called normal. And this was your incident ray. And this is your reflected ray. This we did in the last class. And here angle of incidence is equal to angle of reflection. This was the law of reflection, which we did in previous class. Now, if you see here, students, this line which we draw from center of curvature to the point of incidence, this is your point of incidence. And when we were doing that law of reflection, I also said that these law of reflections are also valid for spherical mirrors. So here in spherical mirror, point of incidence, this is the point of incidence, this is normal, this is your incident ray. So this angle which incident ray makes with the normal is called angle of incidence, and this angle which reflected ray makes with the normal is called angle of reflection. And in this case also angle of incidence will be equal to angle of reflection. Is it clear? So all these rules are based on law of reflection only. I'll not explain in every rule, but in this rule I wanted to explain so that you understand that these rules come from law of reflection only. The basis is law of reflection. Is it clear, students? Everyone? You can just give me a thumbs up so that I understand that you are understanding whatever I am teaching. Okay, good. Let's move ahead. Now, second rule. So first rule, I'll reiterate. First rule was that when you have a concave mirror, a light ray which is incident light ray which is parallel to principal axis, after reflection, it will always pass through the focus. This is the first rule. Now, what is rule 2? Rule 2 states that a ray of light passing through the center of curvature of a concave mirror is reflected back along the same path. So if the incident ray passes through this center of curvature, the reflected ray will pass through, means it will follow the same path in opposite direction. So incident ray will come from here to here and reflected ray will go back in the same direction. So this is your rule 2. So what does rule 2 state is that so let's say this is your focus and this is your center of curvature. So light ray, if it passes through the center of curvature, after reflection, it will go back in the same direction. So it will take the same path. It will reflect back along the same path. Is it clear, students? The second rule is also clear. So let's see the rule 3, students. What is rule 3? It states that a ray of light passing through the focus of a concave mirror becomes parallel to the principal axis. This is opposite to rule 1. In rule 1, when the light ray was parallel, incident light ray, when it was parallel to the principal axis, after reflection, it passed through the focus. Now, what this rule says that if incident ray passes through the focus, after reflection, the reflected ray will become parallel, just opposite to rule 1. Okay, so here the incident ray is passing through the focus and the reflected ray becomes parallel to the principal axis. Again, here law of reflection is being followed, where it says that angle of incidence is equal to angle of reflection. Is it clear? Okay. Let's go ahead, students. Fourth rule. So fourth rule states that a ray of light which is incident at the pole of a concave mirror is reflected back, making the same angle with the principal axis. Why does that happen? We'll understand that also. Now, what it is saying that if the incident ray hits the mirror at pole, So in this case, this line, the principal axis is actually the normal here, because I said that when we draw a line from center of curvature to the point of incidence, this is your point of incidence. In this case, the point of incidence is the pole itself. So when the center of curvature joins this pole of the mirror, this angle is angle of incidence, right? Now, the reflected ray, if you see, this reflected ray will make this angle R, where angle I is equal to angle R by the law of reflection. And that's why it says that reflected ray makes the same angle with the principal axis. Okay, it's nothing but law of reflection only at the pole of the mirror. This law of reflection was valid at every point. At any point, wherever the reflection happens, law of reflection will be valid. So it will be valid at pole also, pole being the point of incidence. Is it clear, students? Is rule 4 also clear? Okay, good. So students, we have covered up to rules for obtaining the image formed by concave mirrors. In next class, we'll talk about the ray diagrams for images formed at different position of the object. So, and then we'll also do convex mirror and the rules for obtaining images in convex mirror in our next class whenever we meet. Okay. So thank you, students. Thank you for joining in. So there was a form which was being, shared with you for the feedback, as well as, to give your data for creating login IDs for the test which we are going to conduct. So we are going to have this proficiency diagnostic test as discussed on the orientation day. We'll be conducting it on Friday, that is 16th of May. So what you need to do there in this form is give us your basic informations like your login ID, the email ID which you would like to create as login ID, your phone number, and all other details which is required, your name and your class and school name. So all of these details, please fill it there so that we can create the login IDs for you. And then you will be able to take that proficiency diagnostic test on Friday. The test is not to judge you. The test is only to only for us to know what are your strength areas, what are your opportunity areas, hurdles and weaknesses, so that we can work on those opportunity, hurdles and weaknesses during this summer course. And when you join back to school after summer vacation, you are all confident and you are going to do well in your exams. Thank you, students. Thanks for joining in. Be disciplined. Keep on joining regularly in the class. Don't miss any class. Otherwise, you will not be able to understand, the next lectures. So be regular in the class and enjoy your vacations. Thanks a lot. Bye and take care.